Hello, and welcome back to this AI Week episode. I'm Emma Brooks. I am the channel manager for the Energy and Sustainability, Construction and Investments and Markets channels here at DCD. And I'm delighted to be joined by four expert speakers today to discuss optimizing AI infrastructure for resilience and efficiency. So, a really important topic for this AI Week. And thank you very, very much to Legrand for supporting this episode. So, with me here today, I have John Berenbrock, who is the Director of Product Management at Starline, a brand of Legrand. John Consoli, who is VP of Sales for Cabinets and the Containment Division at Legrand. Frank Yang, who is the Senior Product Line Manager for Approved Networks, a brand of Legrand. And Prabhakar Muthuswamy, who is a Senior Product Manager at Raritan, also a brand of Legrand. So I'm conscious that we have a big topic to cover here, so I'm going to get straight into the conversation to discuss how is AI changing data center infrastructure. So, John B., if I could come to you for your thoughts first, sorry. It'd be great to get your perspectives on how power distribution solutions are responding to AI.
Yeah, thanks, Emma. I think I like to talk about in terms of AI, how it's changed over the past, like, say, 20 or 30 years. And I think the biggest change that we've seen is in terms of power density. And of course, this is not news to anybody who's been paying attention to the data centers. But if you stack it next to, from a historical perspective, it really opens your eyes. So, when we started, I think, let's say 3 kilowatts per rack was really a standard. Let's say a standard power density for data centers, maybe 20, 25 years ago. And it stayed there, maybe 3 to 7, and would hear about increasing power densities and lots of chatter about how things are really rapidly increasing, and maybe it would hit 10. And then, then along came cloud computing. And that really did kind of change the landscape, and that got up to maybe 17 kW per rack. And I think it stayed there for a long time. And that's where we at Starline have seen a lot of the market kind of settle for a while. And then, 2 years ago, when ChatGPT kind of made a big splash, ChatGPT 4, and it seemed like AI just exploded in everybody's browsers. Every application that you open has an AI component to it now, whether it's Bing, whether it's Google, whether it's, you name it, Adobe, everything has an AI application. And so what we are starting to see is, okay, we went from 17 kW per rack overnight to around 40 kW per rack. And it's like, whoa, that's a big change. And so it puts a lot of stress on not only the suppliers like us, but on our supply chain, going from, say, a 30 amp at a 400 volt solution to a 60 amp at 400 volt solution. So essentially doubling the capacity almost overnight for these AI racks. And, but that's sort of a yesterday's or last year's solution. And the conversations we're having today are now 80, 100, 120, and it's unclear as to where we are headed.
Absolutely. I mean, there has just been that huge increase in density, and it's affecting all aspects of data center infrastructure. And yeah, on that, I'll turn it to you, Frank. I mean, how is the network infrastructure itself responding to AI requirements in terms of speed, latency, and networking protocols as well?
Definitely. Thank you. AI impact on data center infrastructure is profound. From speed, we're talking about 800 gig, right? Before we have a 10, 25 gig, maybe 100 gig to the server. Now you're talking about 800 gig, precisely say 2 by 400 gig to the server. That's a huge increase, right? It's a huge evolving. And also from networking architecture or design perspective, the impact that is around the latency, and more importantly, or equally importantly, it's the consistency of latency, right? So you have to design the entire infrastructure around that latency and the consistent of latency, right? So we're talking about a nanosecond, the measure. And from networking protocol perspective, data center networking used to be dominated by Ethernet, right? Fiber channel has some, and the Ethernet dominating if it's not 100% market share. Now in the AI, you have choices of being led by actually InfiniBand, right? InfiniBand to support AI networking. And Ethernet can be another choice. For example, the Ultra Ethernet Consortium spec that can do that. So yeah, AI impact on data center networking infrastructure is profound.
Yeah, fantastic. Thank you, Frank. And John, again, I'd like to hear your observations as well from cabinets and containment.
Yeah, sure. I am. It's nice to be back. So, from a cabinet perspective, it's really, really a fun time to be in the data center industry. From a cabinet perspective, I'm so happy that I chose to do this instead of going to dental school. Um, although I think it feels more like a root canal doing this now than being in a dentist office. But anyway, what's changed for us is that in a very, very brief period of time, the cabinet has gone from being considered as a commoditized place where the system lived or the system was housed to the cabinet now is an integral part of the designed and engineered system. So no longer is the cabinet viewed as a commodity, at least with the AI customers that we're fortunate to work with. Something we like to say at Legrand Cabinet Containment is that before it can work in your data center, it needs to work in your cabinet. And what we mean by that is that every application, or now as we're being learned to call, it used to be, I've been around where we used to call them programs and it went to applications, and now in AI we call them agents. So the purpose for building the data center is to run these agents and applications. Those applications, everything that supports it, from the GPUs, right? We've gone from CPUs to GPUs, everything's changing, but the GPUs, the fiber connectivity, copper connectivity, the power distribution units, the rack power distribution units. Everything that we build as an industry, the data center for, comes together at one place and one place only. And that's not in the data center, it's at the rack level, right? So in the rack level, everything is coming together. Our customers have shared with us that some of the racks that we've been working on for the past 6 to 8 months, the overall value of a finished rack, we had a customer where one single data center rack had a system value approaching $8 million. And the industry no longer is looking to put an $8 million solution in the cheapest metal box that they can get. So something that we do at Legrand that differentiates us from a lot of the market, we really, really focus on custom cabinet solutions, and we work alongside our customers to help them optimize and utilize as much of the internal space of that cabinet as possible. And there are things now we never had to think about before. You know, like John B was saying, and like Frank said, when you're at 20 kW and below, you've got 2 rack PDUs. Maybe the cabinet is 3/4 physically populated with network equipment or CPUs, and now we're having to deal with a 52U cabinet that's bigger than anything we've ever built before, fully loaded from top to bottom with very, very expensive and vital equipment, 4 and sometimes 6 rack PDUs that need to be accommodated, all of the fiber and copper and power cabling that goes with that. And now I'm sure that one of us, I won't be the last one to talk about finally liquid cooling at the cabinet level and at the chip level. Now a new thing our customers need to deal with is manifolds, right? Where do we put a manifold for liquid cooling inside that same cabinet? So a really exciting time where our engineering team is really, no pun intended, but getting to think outside the box about what needs to wind up inside the box.
Fantastic. Great pun there. Great observations. And you mentioned everything kind of coming together. Obviously, all the infrastructure does need, all the strategy for the infrastructure does need to be aligned and connected. So, Prabhakar, from an overall white space perspective, I mean, what's been the response? We've already touched on, the network infrastructure, the cabinets, and the containers. Yeah, great to hear your views.
Thanks, Frank. That's great question. From an overall perspective, things are growing, and every data center folk or manager are trying to be adaptive to what is currently required. So, like John B. mentioned, when people were talking about 20 kW a few years back, and NVIDIA came up with these GPUs, and which are predominantly initially just used for supercomputing, right? Where like universities and few research organizations where they want intense computing applications running, and they were looking at, okay, we need more than 20 kW to run these GPUs because they are drawing more than 1000 watts, 2000 watts power supplies. So we need to increase that, and they jumped to like 34 over 30, 40 kW racks. And then after the introduction of ChatGPT, it just exploded everywhere. It not just in one space. Every industry across the board in technology want to have something related to AI, and where like people who don't really talk anything about power densities now are much more interested to know about power densities and going into different kind of outlets that would be needed to build these servers. And then also looking at the people who don't even think about resiliency or redundancy are forced to start thinking about it, because that is the only way they can achieve the efficiency that is needed for running all these GPU servers. And and also, like, I know, like, overall in data centers we always talk about PUV, and the PUV, it's very easy these days to get to a PUV of 1.2, 1.3. But now people have started looking at, okay, PUE is a metric, but that is not sufficient anymore. We need to find better ways to um, improve the efficiency and the performance of our data centers. So they are looking into investing in a lot of intelligent monitoring systems. So this way, it's not just a one-time thing where we need to do some kind of efficiency metric, but it has to be an ongoing, continuous monitoring is needed to really run an efficient data center.
Fantastic, thank you. I'm going to move us forward to talk around scaling the data center infrastructure to AI requirements. So, John B., if I could come back to you again for this. There are obviously a certain number of unknown unknowns in terms of what power infrastructure needs to adapt to. We've recently seen the announcement of the NVIDIA Rubin GPUs. So how is the power infrastructure adapting to these power-hungry NVIDIA GPUs that we're seeing?
Yeah, I mean, so when you look at the power infrastructure, of course it's increasing, and you really want to set up your data center to be successful for the long run. So as I mentioned, in the previous slides, that we really don't know. We were at 20, then we're at 40, and just yesterday, literally just yesterday, I got a requisition to see how I could fit 400 amps of power into 32 inches of space. And that's if somebody had asked me that 4 or 5 years ago, it would be like a joke, like not real. And so, as you can see by the McKinsey graph here, it's not projected to stop anytime soon. So what data center operators need to do as they're designing today is how do you scale? And when you're choosing your infrastructure equipment and you're looking at the different types of distributing power over the racks, it's our belief at Legrand that overhead busway is the right way to do that. And there's a couple reasons for that. And one, as I just mentioned, the density. So in that 400 amp example, our engineers, we have a huge team of engineers solving these problems. And I think John C. mentioned it. It's a really fun time to be part of this industry, because we're not just churning out the same stuff, cloud compute all the time. We're solving customer problems. They're new every day, and with Busway, we're able to do some of these things where we're custom designing these what we call plug-in units, which we can literally just take these units, plug them into the Busway, and you can have 400 amps of power dropped. But let's say in 2 years, maybe the GPUs become more efficient. It's only 200 amps. Well, with the Starline Track busway system, all you have to do, your power rails are fine. We can just change out your plug-in unit, and you're still scalable. If it goes the other way, or if the voltages change, your infrastructure doesn't have to change. We just have to change your plug-in unit. So that's kind of what we would like to say in terms of when you're scaling think about your overall power. Of course, we have to size it correctly. But when you're choosing something, choose something flexible like overhead busway.
Yeah, absolutely. I think I mentioned when I introduced myself, but I run the construction channel at DCD, and so often you're hearing about this need for flexible construction and the need to accommodate different workloads. So yeah, really, really important there. I would like to hear Frank's thoughts, if that's okay, on sort of how you would architect your networking infrastructure to enable AI clustering. If you're able to give your 2 cents on that.
Yes, AI application have all-to-all collective traffic pattern. What does that mean? It means all GPU talk to all GPU at real time, right? And also from a performance perspective, the AI application measure the job completion time. Those two things come back to that latency and the consistency of latency that I just talked about. From networking architecture perspective, right? Leaf spine, non-blocking leaf spine is a typical one that can be used by AI computing network. And you can see from the NVIDIA DGX H100, let's say use that GPU node as an example, you can have twin ports of 800 gig goes to the leaf 800 gig switches. You can use multi-mode. Let's say you make it within 50 meters. And you can use 800 gig SR8 or VR8, those type of optics and networking. From the leaves to the spine, you can use 800 gig to 800 gig. For example, the choice could be 800 gig DR8. That's your choice. And you can split them because they are twin, meaning 800 gig is implemented by 2 by 400. You can split them in order to increase your resiliency, redundancy, and perspective, right? So those non-blocking architecture is really is required basically to support AI application for those all-to-all collective and also the job completion time measurement latency. Another point I want to make is this, right? So from AI perspective, AI computing, they use the computer capacity, they use GPU, number of GPU to measure how large it is, right? There need to be a ratio between GPU to optics to maintain that ratio in order to make your network working, right? So for example, it could be 1 to 2, 1 GPU to 2 800 gig optics, or could it be more, 1 to 3, or even higher. If it's a 400 gig, you're talking about you need to double them. So that's a ratio. I want to have the audience to basically pay attention to that in order to make your networking work. Yeah, thank you.
Brilliant. Thank you so much, Frank. John C, I'll come to you next, if that's okay for your views. I mean, we've already talked quite a lot around how scaling up to these customer deployments is so key. So, I mean, what are the factors from a cabinet and containment perspective that need to be considered to help speed up customer deployments?
Well, Emma, that's a great question. As you know, we're in an industry and live in a world that loves acronyms. So I'm about to add a new one for you. It's an acronym that we created at Legrand, and we call it FACE. And what it helps us remember is that when we're interacting with a customer, what we talk about, the F is the footprint. The size of the cabinet itself, we've seen, as I mentioned before, 52U cabinets where it seems like, a blink ago we were doing 42U as a standard, right? So not only are the cabinets taller, but they're deeper and wider than ever before. So what's the footprint going to be? And then what's really important is not all cabinets are created equal, obviously. We focus on the utilization, or helping the customer utilize as much space inside the rack as possible. Then the A is for access and egress. So not only access and egress within the cabinet, how will cables come in? How will cables leave? How will equipment be mounted? We also, and we have a slide up right now that's showing some shock packaging. Another thing that I think is getting overlooked a little bit too much. We're talking about power density and speed and how everything's being increased. Let's not overlook weight, right? The weight of a fully integrated cabinet and the way that, especially for AI deployments, we're finding that most of the cabinets we manufacture go to a third-party integrator for the system to be built before it gets delivered to the data center. Those cabinets, when they roll out of the integrator, can weigh every bit well in excess of 2,000 pounds, in some cases up to 4,000 pounds. So what we need to think about now, how are we going to safely package that multi-million-dollar system? How are we going to move that rack? And what you're seeing here is some special packaging that we've designed that we call rack and stack packaging to protect not only the cabinet, but the packaging is reused to protect the system when it ships from the integrator, and it rides on a shock pallet. If you look at the picture, you can see there are actually styrofoam inserts between two layers of wood in the bottom of the pallet, and then a ramp to help the team in the data center get that 3,000-pound rack off the pallet and ultimately move it into position. So that's access and egress. And then C in face, there are 3 C's. The C's are cabling, cooling, and containment. How are we going to manage cable inside the cabinet? How is the cabinet going to be cooled? Is it water? How's the equipment going to be cooled? Is it water cooled? Is it air cooled? What accommodations need to be made to manage airflow and to make sure that the air doesn't get wasted, that we have good airflow hygiene? And then containment, both containment in the cabinet itself. Is the cabinet going to be an efficient and a effective component of the data center airflow, because that's ultimately where the equipment is? And then also, is aisle containment required? And what we found is, what's really great for me is I run a sales organization for a cabinet and containment business. We're seeing customers where it used to be the decision was, are we going to use hot aisle or cold aisle containment? I can tell you in a lot of the AI applications we're seeing now, we're seeing customers go to both hot aisle and cold aisle to really drive efficiency and effectiveness. And then the last thing, the E in face, is the equipment. And by that, we're talking about the manufacturer brand name. There really are no standards. When we hear GPU now, we automatically, as an industry, think of NVIDIA as they are the market leader. But when we start to talk about the actual system that's going into the enclosure, the equipment manufacturer can make a difference, a huge difference to the design of that rack. Where is the I/O going to be, in the front or the back? How are the racks going to interact with each other? Are there inter-rack cabling that needs to be done? So something to keep in mind is the equipment manufacturer, the OEM, what does their solution look like? Because that's really going to impact what the system that shows up looking like a fully populated rack is going to look like. So FACE, F-A, 3 C's, and an E.
Perfect. I'm sure that acronym will become more widespread. No, that's great summary. Thank you. And Prabhakar, I'm keen to hear your views as well. How are AI and high density expected to proliferate? And what does this mean for power and data center design? Going a little bit more high level here, but yeah, I'd like to hear your views on this.
Thanks, JC. You touched upon a very, very important topic, which I was about to bring next. This is regarding the OEM, because you have Intel, AMD building CPUs, GPUs, and NVIDIA primarily focusing on GPUs and defining what should be the power consumption and the redundancy for the maximum power efficiency for their servers to run for depending on the application. But it's end of the day, it's like JC mentioned, it's the OEM manufacturers who are integrating with these CPUs and GPUs are defining exactly how these things are going to be. And that is what it's making things even harder, because previously when a data center manager is buying some of the servers, they don't have to do much calculation and they just go and see like, okay, I'm getting a 30M 208 input feed coming in, and I can stack like 24 to 30 pizza box servers on it, and that's it. And I just need to have an A and B redundancy. I'm done with it. But now that's not the case, because each out of these OEM servers could be anywhere from 3 to 4U, which means that they can't stack more than 6 servers on the rack. And when you load in these GPUs and CPUs on it, they are going to define that, okay, you need to have either an n plus, where n could be 2 or 1, or n plus 2, where n can be 1. So depending on how the servers are constructed, the efficiency is dependent on the redundancy of the power supply. So what I meant to say is, if a server has 6 powerful supplies, some of the GPU manufacturers define that whether you need to have 3 or 4 power supplies completely redundant to have maximum efficiency. So these are all, along with the network equipment that Frank was talking about, is all driving the power density of the rack. In the initial conversation, JB was saying that, like 4 years back, if somebody talks about 20, 30 kW, oh, great. I mean, finally, we are seeing people thinking about high performance computing and talking about 20 kW. But today, we are talking about 100 kW per rack, which is becoming a norm in 2024, which was not the case even last December. But today, 100 kW is becoming norm, because what we are observing is the application developers and the companies have realized that these the constant research in both CPU and GPU power consumption is going to evolve. We are in a very, very infant stage of this whole process. So we need to find a way to build a very efficient rack, but at the same time, we should also make it a future proof. Meaning, if today, okay, my OEM server is supplied with a 3000 watt titanium power supply, 6 of those, and tomorrow it may need a 5000 watt power supply. So I don't want to build a new rack for it, but instead, if I can just remove the existing server and replace it, that would save us like $8 million that JC was talking about, whether you want to put in so much money again or you just want to go to replace the server. So that is the kind of power density we are seeing today. So I mean, we were JC would really agree with me here. Like few years back, before the whole GPU situation, we were thinking, okay, data centers are going to consolidate. No, nobody is talking about consolidation anymore, because everybody wants to get into this AI wave and build efficient applications, which is going to give them a lot more data information from their customers and make more money. So they're all looking at that thing. What do we invest, and what is going to be ROI for our investment? And for that, right from bus and all the way to the PDUs. PDUs are usually the last piece in the rack, and everybody is looking at how do we go about running and very efficient and performing racks, not just one, multiples of them in a data center. If I have some time, I just want to touch base a little bit on this one example. We just recently did this project for one of our customer, which is like we know that they are going to get a A100, which is the very starting point of GPU from NVIDIA, and they built with 4 power supplies, and they can't change their existing infrastructure. They had an existing 208 volt 60 amp, but given their existing rack and the power infrastructure that they have, they ended up having 4 PDUs in a rack, which is really not that common few years ago. But now, in order to get a 40 kW rack, they need to have 4 PDUs given their existing infrastructure, right? So more and more, that's what we are seeing, where how do we use the existing infrastructure? Can it be repurposed to build an AI rack, or do we need to really go and start things from scratch? Thanks.
Fantastic. Thank you, Prabhakar. And I want to dive a little bit deeper on something that you mentioned in your point around future-proofing design. As we've already mentioned, there are a lot of unknowns in terms of kind of where AI is going to go, and maintaining that resilience as well as being able to build out and scale up for customers is absolutely crucial. So Frank, I'll come to you for your thoughts first on a fiber perspective, if that's okay. How are you scaling out, and what are the migration paths for that?
That's a great question. right? So we talk about 400 gig, 800 gig from a speed perspective. But I didn't mention about how many fiber really going to use to carry out those 800 gig, 400 gig, those signals, right? So if you think about the data center before, let's say 10 gig, 25 gig, or even 100 gig, using this multi-mode right now I'm showing here, for 10, 25 gig, or even 100 gig, you can use a pair of multi-mode fiber to operate them, right? 10, two fiber, one pair fiber, run 100 gig. You could do that. And for 400 gig, things start changing. This is we're talking about a multi-mode here. So 400 gig, you need to use 4 pairs of fiber, multi-mode fiber, right? You can either QSFP 112, SR4, VR4, or OSFP 112, SR4, VR4, or SR4.2. All those things, they need 4 pair. And then you're moving up to 800 gig. I mentioned about 800 gig SR4 to connect from the leaf to the DGX H100 GPU node. That's 2 by 400 gig. That's actually using 8 pairs in terms of. So you have to plan out those fiber plan in order to be able to, from now on, you have not support to the future proofing to support AI or even beyond, right? Single mode, same thing. 10 gig, 25 gig, 100 gig. You may use a 2 fiber, which is a pair single mode. You can run it. For 400 gig, it starts changing. Yeah, you use 4 pairs, and 800 gig, we talked about a DR8. It's also actually a 2 by 400 gig DR4. So you actually use 8 pairs of single mode. So no matter it is a multi-mode, single mode, when you consider to evolve, you have to consider the fiber plan numbers, right? So it's a pair, 4 pair to 8 pair to support up to 800 gig, right? That trend is gonna going up. Another thing I want to mention that to design the AI networking architecture, we're not talking about the cable distance like a kilometer. No, we are talking about meters, 50 meters, within 50 meters. Even single modes, it's in order of meters. We're not talking about kilometer because of the latency. I keep talking about the latency and the consistency of latency, right? Get back to. Thank you.
Brilliant. Thank you so much, Frank. John C., I'm keen to hear your views on from the cabinet perspective. What are the key elements that enable more resilience to these changing AI requirements? How are you accommodating increased IT equipment loads? And again, you've already mentioned, some of the weights that you're seeing, but what are the types of loads when transporting as well?
Well, the loads are quite large, and in an industry where we throw numbers around and big numbers so much, Emma, they kind of lose their impact, right? So, as I said a few minutes ago, it's not uncommon for us to see our racks certified at shipping weights in excess of 3,000 pounds. It's very common for them to be 4,000 pounds. So as you nice people can see, because we're on video here, I'm an older gentleman with salt and pepper hair, and it's time for me I can't call it a midlife crisis, Emma, because that would mean I'm not going to live until 120 years old. But I did just celebrate a birthday, and I bought myself a Chevy Corvette that I've always wanted my entire life. How that's relevant is when I registered that Corvette, the curb weight of my C7 Chevy Corvette is 3,676 pounds. My car. The cabinets that are being delivered weigh more than an automobile. The cabinets that we deliver weigh more than an automobile. And some of the projects, not that we're working on, a project that we just completed, the first phase of the data center took 2,300 racks at an average weight of a Corvette. So we're talking about moving massive amounts of weight with a very, very, now the other thing is that I don't know, at the $8 million rack, my Corvette price wise is a fraction of the cost invested in that rack. So very, very expensive, very, very mission critical, very, very heavy equipment being moved in the metal boxes that we build, right? So the integrity of the cabinet needs to be taken into consideration. I encourage everybody, regardless of where you buy your rack or cabinet, hold the manufacturer responsible to show third-party documentation that shows the static, dynamic, and transportation weight loads that has been certified by a third party. Like Mr. Reagan said years ago, trust but verify. We all make a lot of claims, but it's vital to verify that because the amount of weight that we're moving and the risk involved in damage is just at a level we've never seen before.
Yeah, as you said, really, really important, and that's I didn't think I would hear a car analogy on this episode. So
yeah, I worked on that one pretty hard. I hope everybody liked it.
Yeah, no, that's great. Thank you. Prabhakar, I'll come to you next if that's okay. I mentioned the efficiency earlier, and then the importance there. So stranded power is often something that's brought up when it comes to data center operations. So, I mean, how can addressing stranded power help to improve overall efficiency and resilience for AI as well?
I mean, Emma, great question again. We all know that every hyperscaler or a colo provider or anybody in the data center space, we are in an ongoing quest to improve data center efficiency, right? We find ways to do it, and we all know the biggest challenge is confronting the stranded power. Right? And the good part, which is driven by AI, is everybody seem to understand the importance of monitoring every power aspect within the rack, right? So that is something which is really helping them to run an efficient rack in the first place. What I meant to say is they start with monitoring in the busway, then all the way to your UPS, then the rack power, and then depending on their monitoring capabilities, which I meant to say is like their building monitoring capabilities, they um, add in environmental sensors or other stuff to really run to get a very data driven data center. But to avoid stranded power, there are a lot more things that they need to follow, which would really help them in running a very efficient rack. It all starts with a process, right? You need to have an established process which has to be repetitive and routine, which needs to be followed across the organization to look at the metering data and make useful decisions. That's number one. The number two is the dynamic nature of the demand. Like with the current applications and the servers, the demand is always fluctuating. So you need to have proper resource allocated, demand forecasted, and also the capacity planned to make sure that your capacity of the rack is aligned with the operational needs. So this needs to be done way ahead when you're actually planning your infrastructure. The third aspect, which we touched upon on the previous thing, is also the evolution of the technology. So the technology is constantly changing. At the same time, when we are designing it, we need to find a way to utilize the existing resources so that it is compatible with the future technology. And the last part is how do you mitigate all these strategies and come up with you need to have an holistic approach, a strategic planning, and an organizational alignment so that you are not just doing this upfront. You continuously do to monitor and align with all the respective team members so that you can avoid stranded power to run a very efficient rack.
Fantastic. Thank you so much. John B, we've already mentioned, John C has already touched on the huge increasing weight of these cabinets. What are the other primary issues that data centers are facing due to these rapidly increasing power densities? Are there any other new safety concerns?
So I think one of the things that we really need to pay attention to as the power raises across the board is the changing topologies as power gets distributed to the racks. The PDUs are still usually rated for 10 kA or 5 kA, whatever they are, and we really need to think about limiting that energy. And so I'll talk about a multi-pronged approach to this. So when busways, when we look at this, incident energies, or I'll say fault currents rather, are a lot higher than they used to be, and voltages are a lot higher than they used to be. So when we started, back when the racks I talked in the first slide were 3 kilowatts, and on the West Coast you had surfers and flip flops and board shorts, turning in our equipment, which is really was about as safe as plugging into your outlet, and so nobody's afraid to do that. Fast forward to today, where you have 480 volt power rails and you have 65 kA fault currents. It's quite a different situation. And so a lot of our customers do maintenance shutdowns because incident energies are rising. And so the cost of a mistake is much higher today than it was previously. So what we've tried to do is address that through fusing. Fusing can reduce the fault clearing time to where it's, if the fault clears quicker, then it's a much safer solution. So, Probocar's PDUs can withstand 10 kA. Well, we can get a 65 fault current down to 10 kA or below pretty easily by adding fuses to our tap-off units from our power rails. So that's one example. Another example is adding flexibility back into the system by not doing maintenance shutdowns, by using our what we call an RPA, our remote electrical engagement tool. And that can basically enhance operator safety by allowing the operator who's installing our plug-in unit, if they want to do it live, they don't have to take down the system. They can step outside of the arc flash zone, use the remote control, engage the plug-in unit into the busway, come back, remove the tool, flip on the breakers, and they're good to go. So, it's a multi-pronged approach. We want everybody to go home at the end of the day. That's really the most important part. We talk a lot about making money, but really the nuts and bolts of it is there's people in these data centers performing these tasks, and everybody at the end of the day, we want them to be safe.
Absolutely, well said. We've got about 5 minutes left, so I just want to take a bit of time to look at how the data center can be scaled efficiently. John C. and Prabhakar, I'll come to you for your thoughts on these, if that's okay. So John C., when it comes to the efficiency with racks and cabinets, what are the elements that need more attention to detail with high power density? What are the elements that perhaps maybe the industry's overlooked that are really key?
So Emma, thanks for that question. And the things that get overlooked there are attention to detail, right? So one of the things that we really found we need to focus on is with the amount of airflow that's moving through these cabinets, it's really, really important to be more diligent than we ever have before in sealing any possible place where air could be leaking out of the cabinet. So number one, we recommend that, again, whether it's a Legrand rack or not, we found that the best test results we get are with a rack or cabinet frame that is fully welded, right? Because logic just dictates that when two pieces are fully welded together, if it's done properly, there's no leakage that can occur. And then we make available, and so do these are things that are commercially available from any cabinet manufacturer, not just Legrand. But we encourage everyone to pay attention to sealing packages, not just blanking panels and empty spaces. And quite frankly, the racks are being populated now. There aren't a whole lot of empty spaces in the mounting area, but any place that there's cable access or egress, use cable seals, use brushes. Sealing between bayed cabinets is extremely important. As you see bottom left, we've got air sealing plinths for airflow that might move underneath the cabinet. We just really need to be diligent and ensure that, it costs a lot of money. You talk about PUE, and if we look at PUE, a large chunk of the power expenditure to run a data center, a percentage of it goes to the IT load, but what doesn't go to the IT load, most of that's going to cooling, right? So it's costing us a lot of money. It's a vital part of the safety and resiliency of the system. So we need to make sure that every bit of air, every bit of conditioned and cool air that the data center team is paying for makes its way to the inlet of the equipment. And then we want to make sure that we're doing everything that we can to prevent the mixing of hot and cold air. And there are many new approaches now, especially as we start to see a ramp up in the implementation of things like rear door heat exchangers, be they active or passive, and in-row coolers. So to wrap up my part, and I'll hand it to Prabhakar, the most important thing that I think we need to focus on right now is airflow integrity and airflow hygiene at the rack level.
Perfect. Thank you, John C. And just to wrap up, Prabhakar, it'd be great to hear your thoughts on how enhanced monitoring and management at the rack PDU level can contribute to not only this efficiency element, but also extending the lifespan of IT equipment, which is obviously key to sustainability as well.
Thanks. I think we all have come to an agreement that intelligent monitoring PDU is a must when you're building an AI rack, because it's going to help you with efficiency, your performance, your resiliency. So you need to not think about just have an intelligent rack PDU. Then depending on the levels that you need, whether you want the input level or you want the capability to avoid stranded power, whether you need the capability to turn on and off the outlets, or you need the very outlet level monitoring of the data, that's all depends on your choice. But having to monitor the data is very important. But the one thing which JC was mentioning is when people start thinking about AI racks these days, the two things that they come to our mind is what's going to be the input power that I'm going to bring from the busway, and then how I'm going to actually cool these high heat dissipating servers. That wasn't the case before, but now everybody is thinking about cooling, right? So then when that means that there's going to be high dissipation of heat coming out from your servers, which means your environment around the rack needs to be monitored, which wasn't the case before because we were all very reliant on free air cooling, but now that's not the case anymore. So to have a very efficient rack, not just monitoring the power of your servers is critical, but at the same time, you need to also measure the environment around the rack, which could be the temperature, humidity, and if you're going with liquid cooling, then you need to think about condensation, water leak, and things like that to really make sure that you have a 99 or 100% uptime of your rack. One other thing which I want to stress is like the incidents that John B was mentioning, we also need to think about the quality of power that is coming into the infrastructure, right? We have spent so much millions of dollars on these equipments, and you don't want to do an yearly audit to measure, okay, am I getting whether my quality of the power that I'm coming into my rack is meeting my standards so that I can guarantee 100% up to my service providers. So to just summarize, intelligence, not just the rack level, you need to look it up of the complete rack intelligence to run a very efficient data center.
Fantastic. Thank you, Prabhakar. I feel like that is a great note to end on. Unfortunately, I am going to have to wrap it up there because we have run the clock down. But Frank, Prabhakar, John C, John B, thank you very, very much for joining me and taking the time to contribute to our AI week here at DCD. It's been a pleasure to speak with you. Thank you very, very much to Legrand for supporting this episode. Do check out the resources at the bottom of the page. Send in any questions, reach out to the team at the Legrand. They'd be delighted to hear from you. And don't forget, if you had to tune out for whatever reason, this episode is available on demand. Our next episode will be starting in just a few minutes. But again, to Legrand and to Frank, John C, John B, and Prabhakar, thank you very much for joining me.